I'm Corbin Wodenauer, the lead programmer for Team 1425. This video explains how we use Simulink for the made-to-order Best Robotics game at DuBois Area Robotics. We began by using the Best IQ Challenge in Cody to improve our understanding of coding with MATLAB. Here you can see a sample of one of the challenge items. Throughout the design process, we use Simulink to control and test our prototypes. Here is the simulation of the code we use to test the infrared transmitter. It uses a state flow block to toggle through an array of all possible transmitter code. Through consulting with the robot designers and the drive team, the robot code developed to have three distinct drive modes: a default driving mode, a reverse driving mode, and a squeaky mode for interacting with the field robot. Each of these modes was placed in an if action subsystem that was activated by a combination of specific button presses. The robot begins in default mode, which operates with the arm facing forward for interacting with the game pieces. This portion of the code ensures that the lever manipulator servos are held retracted to keep the robot in compliance and avoid accidental impact damage. The drive system is a simple tank drive, but we use a custom function to modify the joystick signals so that they are not linearly proportional to the motor signal. This allows more precise speed control while still permitting full power. We also employ deadbands and rate limiters to further improve performance. The arm is controlled by two digital buttons and two limit switches. This provides simple controls while preventing mechanical damage from driver errors. The reverse mode is very similar to the default mode. The major difference is that joysticks are mapped to opposite motors so that the back of the robot can now be considered the new front. This adaptation makes it easier for the drivers to align the robot to the field control box. Squeaky mode is engaged once the robot has been aligned to the field control box. In squeaky mode, all drive and arm motors are disabled and the controls are remapped so that the joysticks and digital buttons control the lever manipulators that control squeaky. In this way, the drivers don't have to focus on moving a particular lever. They can simply consider the controller to be operating squeaky directly. The left stick moves the lever that drives squeaky while the right stick causes squeaky to rotate. Squeaky's arm is controlled by the same buttons that control our robot's arm. 3 of the channel 8 buttons control the IR signal sent to the field controller. This state flow chart detects each button press, sets the correct drive IR code, and then activates the transmission subsystem. After a short delay, the signal is altered to change the rotation speed. This way, one button press changes 2 speeds.